Hello, I'm Achit Nair from Nair's Aviation Ground School. This is the 13th video in a new series of educational aviation videos for the aspiring pilot. Since the beginning of flight, one of the biggest problems with the creation of a feasible flying machine was a lack of proper propulsion. By the time the Wright brothers' Wright Flyer took flight, the internal combustion engine was cemented as the engine that powered the first modern airplane into the skies. This video is about aircraft internal combustion engines. The internal combustion engine has been one of the major breakthroughs in human history. The internal combustion engine put people on wheels, allowed nations to build and societies to expand, and has made the world more connected than ever before. And the internal combustion engine has aided the aviation world in a truly astounding way. Modern aviation would not even exist today were it not for the light yet powerful engines that made the dream of flight a reality. Internal combustion engines are the mainstay in the automotive world. The internal combustion engine is also widely used in the aviation community, especially in the lighter, lower powered general aviation aircraft. The majority of aircraft flown by certain pilots will be powered by an internal combustion engine. Therefore, it is important to understand how an internal combustion engine works. Combustion, also known as burning, is the basic chemical process of releasing energy from a fuel-air mixture. In an internal combustion engine, the ignition and combustion of the fuel occurs within the engine itself. The engine then partially converts the energy from combustion to work. The combustion process of an internal combustion engine takes place in an enclosed cylinder. Inside the cylinder is a moving piston which compresses a mixture of fuel and air before combustion and is then forced back down the cylinder following combustion. On the power stroke, the piston turns a crank, which converts linear motion of the piston into circular motion. The turning crankshaft is then used to turn the aircraft propeller. The internal combustion engine is also called a piston engine. In the beginning years of aviation, several variants of the internal combustion engine were used. High-powered radial engines, Vankel rotary engines, and huge inline V configuration engines were used. Initially, all internal combustion engines used a carburetor to control the fuel flow into the cylinders. Most planes in the general aviation world employ a carburetor to provide a combustible mixture of fuel and air. It is the job of the carburetor to measure the amount of incoming intake air and meter out the proper fuel-air ratio to the cylinder intakes. Carburetors require a lot of management and need to be adjusted depending on the elevation and temperature. The cold air in the carburetor had a tendency to freeze and cut off the fuel flow, and therefore the engine. Carburetor heaters were needed to combat this. Furthermore, the carburetor did not work efficiently in colder weather, requiring a much lengthier pre-flight and adjustment. The carburetor has been replaced by fuel injection in all modern cars. The adoption of fuel injection in aircraft occurred at a slower pace, and it is not uncommon to still find carbureted aircraft flying. The fuel injection has taken away much of the headaches caused by carburation. On engines with fuel injection, the fuel is introduced to the cylinder by means of an injector. Benefits of fuel injection include smoother and more consistent throttle response, easier cold starting, more accurate adjustment to account for extremes of ambient temperatures and changes in the air pressure, more stable idling, decreased maintenance needs, and better fuel efficiency. Managing the fuel-air mixture that the engine uses is an extremely important aspect of aviation. Aircraft operate in a variety of altitudes and air densities, and so using a set fuel-air mixture is not feasible. Having a fuel-air mixture with more fuel is known as a rich mixture, while having a fuel-air mixture with more air is known as a lean mixture. Running an engine with too rich a fuel mixture can damage the spark plugs. The spark plugs provide the spark which ignites the fuel-air mixture in the cylinder, and an inoperable spark plug could lead to an engine failure. So, in order to ensure that the engine is properly running in all altitudes and density conditions, the pilot is required to lean the mixture at different points throughout the flight. The aircraft is leaned with the use of a mixture control within the cockpit. The topic of leaning the mixture will be covered in depth in an upcoming video. The most common flight training aircraft in the world is the Cessna 172. This will be the first aircraft that the majority of student pilots will fly. Therefore, it is important for aspiring pilots to be familiar with the engine of a Cessna 172. The current generation of the Cessna 172 uses a Lycoming IO360 engine. The I in the engine designation represents that the engine is fuel injected. The O designates that the engine is configured in a horizontally opposed format. The 360 refers to the cubic capacity of the engine. The IO360 has 360 cubic inches of displacement. The 360 cubic inches translates to 5.9 liters in metric terms. The IO360 has 6 cylinders. The IO360 generates a range of power, but the most common output is about 180 horsepower. Piston aircraft do not create sufficient power when flying at very high altitudes. In order to mitigate this, several high-performance engines use forced induction to introduce richer air into the fuel-air mixture. The air at high altitudes is very thin, so turbochargers and superchargers are used to increase the density of the air taken in by the engine. These turbos and superchargers are also used in the automotive world to increase the performance of road vehicles. The engine is an integral part of the airplane. The pilot needs to know the operation of the engine that powers their aircraft. Aircraft engines have come a long way since the dawn of flight, and the internal combustion engine is one of the most common types of engines in use today. It is important that the student pilot is familiar with the engine and its operation. For more information, please contact us at liftanddrag@gmail.com and visit our website at nyersaviation.webnode.com. Thank you. Safe flying.